Hello everyone. Today we are going to continue our class of set, which is the book NCERT from the NCERT class 11th. Let me just take it. So NCERT class 11 sets. Okay. So in sets today our learning target is to understand what is subset and what is universal set. Okay. So let's see it. Here you can see we have a father. If I change the color, it will be better. So we have a father, and here there is 3 child, right? So when we talk about the subset, so if we have a set, for example, A equal to 1, 2 and 3, then the subset of this set will be, for example, B equal to 1, okay, and or C equal to 2 or D equal to 3. All these are the subset of this set. Okay, maybe E equal to 1 and 2. It means all the combination of 1, 2 and 3, which can be formed in 1 digit or 2 digit or 3 digit, can be the subset of this set. And additionally we have one another set. We will talk about this later, right? So let's move on next slide. Here you can see a set A is said to be a subset of a set B if every element of A is also an element of B. Means here a set A is a subset. Okay, means A is a subset. Okay, so it will be a subset. This A will be subset of a B. This is the main set. Okay, this is a set. So if all the element of this will be also there in B, then we can say that A is a subset of B. You can also say in another language that A is a child of B. Okay, so in this our example here, I have just written with the another name. So you can see in this, if I change the name, it will be more better, because here we are taking another example. Suppose this is B. Okay, let me just clear all this. Suppose this is the B and this is A. Maybe this C, suppose D or E, or for now we can only take one example as per our definition. Just let me remove all these things. So let me remove everything, by the way. So what it's saying? It's saying that if you have a set B, okay, so set B can be written something like B equal to 1, 2, 3. Suppose, okay, so it's saying A can be a subset of B if all the element of set A is also an element of set B. Look here. So this is a subset and this is a set, right? A set A, this is the name of set. Okay, a set A is said to be a subset. We can say it, this is a subset of set B. We have another set B here. Okay, if every element of A is also an element of B, so every element of A is also an element of B, right? Next, here we understand now how to denote subset. Okay, so in set, how we denoted it? With curly braces. So in this subset, how we can represent this? So A, B, okay, and this symbol is a symbol of subset. Okay, if whenever A is an element belongs to A, means there is a set A and there is element A here is belong to A, then A will be also belong to B. A will also belong to B. Then A will be a subset of B, right? Next, it is often conventional to use the symbol this, which means implies A is a subset of B if A element belongs to A implies A belongs to B. We read the above statement as A a subset of B if A is an element of A implies that A, again this element A is also an element of B. Okay. Now consider the set. This is the symbol of mu. We have already seen this. We have a set. This is a set. Mu means empty set. A equal to 1 3, B equal to 1 5 9, C equal to 1 3 5 7 9. Insert the symbol subset or not subset between each of the following pair of set. So this is a empty set. So we have to note that empty set is denoted like this, is subset of, this is subset of any set. Okay, if you have a set A equal to 1 2 3 or a set B equal to A B C, this is the subset of this and also this. So this is a subset. A is a dash B. So let's see, A 1 and 3. Here we have 1 but we don't have 3. So this is not a subset. Now A and C. Let's see, in A we have 1 and 3. Here also 1 and 3. So this is a subset. Now B and C. In B we have 1 5 9. 1 5 9. So okay, this is also a subset. Let's move on next slide. A equal to A E I O U and B equal to A B C D E. Now it's asking, is set A subset of B? Is this A all the element of this set also is an element of this set or not? We have to check. So we have A, we don't have, we have E here, I, we don't have I, O, we don't have O, U, we don't have U. So this is not a subset, it will be false. Okay. Is set B a subset of A? Now it's saying, it just reverse the question, is saying that check whether all the element of B is also there in A. So here A is there, B is not there, C is not there, D is not there, E is here. So this is also false. Okay. Now let A, B and C be 3 set. Okay, so we have A, we have B, we have C. Don't know what is the elements. So it's saying if A belongs to B. So first of all, here it's saying A, B and C be 3 sets. Okay, so when we talk about sets, so we cannot use this symbol. Okay, this statement is totally false. If you are talking about subset, then you can use this, or you can say this is not a subset of B. You can't say that A belongs to B or A does not belongs to B. Both statements are wrong. Okay, so A belongs to B and B is a subset of C. Is it true that A belongs to C? If not, give an example. So this is an example. A cannot belongs to B because A is a subset. Okay. Now here we have another example. Now we have moved on intervals as a subset of R. So we have to now see what is an interval as a subset of R. So suppose this is a number line. Okay, this is a number line. Here we have 0. Let me just undo. What is this? Okay, so it's saying that there is a number x which is greater than 5 and less than 9. So suppose here we have 5 and 6, 7, 8, 9. Okay, 6, 7, 8 and 9. So x, we in this set we will form a set where the element will be greater than 5. So 6, 7, 8 and less than 9. So there will be only these elements in that set. So in interval as a subset, we will represent this like something like open 5 comma open 9. Both sides it will be open. It means this bracket means 5 is not included and this rounded bracket means 9 is not included. Okay, now we have another example. Let me just clear this. I think this is not a good practice to clear all these things, so let me just move it and make it smaller. Okay, so we can keep it here. Now in second example, it's saying that x is greater than 5 and x is less than equal to 9. It means the element in the set will be 6, 7, 8 and 9. Why we have included 9? Because here symbol is less than equal to, means x is less than equal to 9. So 9 will be included. So we will represent it like 6 is not included, 5 is not included. So we will make open 5 comma 9 which is included. So we will make square bracket. Okay, now in another example we have 5 which is included equal to and 9 is not included. So in this set we will form like 5, 6, 7 and 8. So we can represent it as a 5 is included, so the square bracket will be here 5 comma 9 which is not included. Okay, so this is closed and this is open. Now in another example 5 is included and 9 is also included. Both have a equal to sign, so we can write it like 5, 6, 7, 8, 9 and we will represent this as a square bracket 5 comma 9 square bracket. Okay, so this representation is called the intervals as a subset of R. I hope you have understand this. Now universal set. So universal set is a set. Suppose we have a set 1, 2, 3 and 4. Okay, we have another set which is 5, 6, 7, 8. We have another set 1, 2, 3, 5, 7, 9. Okay, so what will be a common set that can contain all the elements of all these three sets? So we can say that this is a set. This is a set of all natural numbers. Okay, so set of all natural numbers. So this is natural. All these are the natural numbers. Okay, and this set is called the universal set, which is, sorry, let me just clear this and this is represented with U. Okay, now we will start solving the exercise. It's saying that make a correct statement by filling the symbol subset or not a subset in the blank space. So 2 3 4 dot 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 1 2 3 4 5. So is it a subset? Is this a subset of this one? Let's see. 2 2 3 4 4. Yes, this is a subset. Now here A B C. A is not there, B and C is there, so this is not a subset. Let me just zoom it. Yeah, so this is not a subset. Third one, X such that X is a student of class 11th of your school. Okay, all the student of class 11th. Now here X is a student of your school, means from all the student we are taking only student of class 11th. So this is a subset. We will do like this. Now X is a circle on the same plane. Okay, and X is a circle in the same plane with radius of 1. So this represents a circle, and this represents a circle with a 1 unit radius. So from this small, how can we take a subset of this big? So this is not a subset. Cross. Okay, so this exercise is very easy. I hope you will do it with your own. Let me just clear it, and if you have any doubt you can just comment it and we will try to solve it, or we can send the solution in the comment box also. Okay, let's move to the another question. Question number 2 here. So examine whether the following statements are true or false. A, B does not a subset of A and B. So this is a false. Now A, E is a subset of X such that X is a vowel. Okay, what is vowel? A, E, I, O, U in the English alphabet. So this is true. If we write this in tabular forms, and it will be A, E, I, O, U, right? So here we can see A and E is there. Now 1 2 3 is a subset of 1 3 5. This is false. Why? Because we have 1 here, okay, 3 here, 3 here, okay, but 2 is missing in this set, so this is false. Now A is a subset of this, so we can see this A, the single element is also there, so this is true. Now A belongs to ABC, so we know that if we are talking about a set, and we are comparing with a set whether this is a subset or not, so we cannot use this belongs to. Okay, this is not allowed. If you are talking about set, just check whether this set is a subset of this one or this is not. Okay, you can't do this, or you can also can't do this. Belongs to or does not belongs to is not allowed in set, right? Let me just clear this. Yeah, okay, so this is a false statement. Now X such that X is an even natural number less than 6. So even natural number 2 4 less than 6, so this will be 2 and 4. Now below a subset of X is a natural number which divides 36. So 36 can be divided with 1 2 3 4 4 6. Okay, so 2 and 4 is here, so this is also true, right? Let's see the next question. Question number 3. Let A equal to 1 to and 3 4. So this is a different statement. Let me just mark it with a different color so you can see it. I think red is great. So we have one element 1, then 2, then this is a single element both, and 5. Which of the following statement is incorrect and why? Okay, so 3 and 4 is a what? A element. Okay, so element cannot be compared as a subset. Okay, now 3 and 4 belongs to A. True. Why? Because if we have the element, so we can check whether this belongs to A or not. Okay, so this is true. Now we have this element 3 and 4, and when we put the curly bracket here, so this is a set. So is this set belongs to is a subset of A? Yes, true. Now 1 belongs to A. So in A we can see we have A, so this is true. Now A is a subset of 1 is a subset of A. This is false because 1 is a element, and if we have an element, how can we check is this a subset or not, right? If you want to check whether this is a subset set, it should be a set. Now 1 2 3 in this curly bracket, 1 to 5, sorry, 1 to 5 is a subset of A or not. So this is interesting. I want you to just comment the answer of this question. Let me just clear this so you can see it. So this is my request to you to just solve this without seeing any answer and comment it below. Is this true or false? And if true, then why? And if false, then why? Okay, I hope you will comment it below and you will check your knowledge of set. Now we have 1 2 and 5 is all these elements belongs to A, but if you will put this one, this bracket, then it will be a set. And if this is a set, so we cannot check a set with a set is it belongs or not. This is false. This is wrong statement actually. This is incorrect statement. So all the false is mean this is incorrect. Now we have 1 3 1 2 3. Is it a subset of A? 1 2 3. So 1 2 and 3. So everything is fine here. 1 2 is fine, but this 3 and 4 is a single element and you cannot take 3 like this. Okay, so this is also a incorrect statement. Let me just write it false. Now empty set belongs to A, so this is a set. How can you compare a set? How can you check that whether a set is belongs to a set or not? If you want, you can check is it a subset or not. You can't check is this belongs to or not. Okay, so if we have set and we have another set, so we can't do this. Okay, or also we can't do like this. If we have a set and we have a set, so we can do is this belongs to or not belongs to. We can do this comparison, but this comparison is invalid. Okay, and if we have a element, so we can check whether this elements belongs to this set or not. Okay, element set. Okay, so is this belongs to or does not belongs to? We cannot do let me just write it nicely. We can do belongs to, just clear it and write easily. So we can check whether this element belongs to this set or does not belongs to this set. Okay, we cannot do like this element and this set. We cannot do this or we can't do this. Okay, so just keep in mind, this is very important, otherwise you will confused and you will just mark the wrong answer. Okay, so now this set is this set, so this is incorrect. Okay, let me write it false. So this is a set, so is it a subset of A? So I told you then all the empty set, this is an empty set, is a subset of any set, so this is true. Now we have a set and we are trying to make it a set, so this is power of set. So we cannot compare a power of set with a set, we can't check whether this is a subset or not, so this is also incorrect. Okay, let's move ahead. Just remember all these four things. Write down all the subset of the following sets. So for this set we will write A itself and an empty set. Okay, for this we will write A, then B, then A and B and a empty set. Actually empty set can be written at first, right here, a empty set, second one, third two, three, fourth 1 2, then 2 3, then 1 3, lastly the set itself 1 2 3. Okay, so and for this there will be only empty set, because this is already an empty set, so only one element will be there. So let's see how we can check whether our answer is correct or not. So if we want to check that if we have a set and we have some elements, so how many subset can be formed with this, we will just write 2 to power n. It means 2 and its power number of elements 1 2 and 3, so 3, it will be 2 into 2 into 2 equal to, so you see here 1 2 3 element is there, so there should be 8 subsets, so 1 2 3 4 5 6 7 and 8. Here we have one element, so 2 to power 1 equal to 2, so we have 1 and 2 elements. Here 2 element is there, 2 to power 2 equal to 2 to the 4, so 1 2 3 4. Here n to power 2 n to power 0, it means 1, so we have one element, right? Now question number 5, write the following as a intervals. Okay, we have already seen that what interval means, closing and opening. So x, just let me convert it in a set tabular form, so it will be easy to understand and draw its intervals, right? So come here. Now we have x such that x is a real number and x is greater than -4 and less than equal to 6. So the elements will be, first let's write the elements, -3, -2, -1, 0, 1, 2, 3, 4, 5 and 6. Okay, and the representation will be 4 is not included, so we can just open -4, 6. Okay, so no need to write this also, I just written to just make you understand how to convert in a set builder to roster form or tabular form. Okay, you will just see whether it in the left element is there only less than or greater than, or there is equal to also. If there is equal to, it means we have to write the close bracket. If there is not equal to, then we have to write the open bracket. That's it. Okay, next question, question number 2. X is a real number and here this is only one less than symbol, so we will make the open -12 comma here also this is greater than, not greater than, equal to, so comma minus 10 and open. Okay, for the third one R, and this is here you see equal to sign is there, so square bracket 0 comma, there is no equal to sign, so 7 and close, sorry, open. Now question number 4, x belongs to R, 3 is less than equal to, so you can, sorry, so you can write 3 comma 4 is also included, then this is comma 3 and 4. Okay, let's move to another example. 1.3 question number 6, write the following intervals in set builder form. So we have already provided with, we are provided with the intervals we have to write in set builder form. So I hope you know what is set builder form, like a statement. Okay, so for 1, 3 and 0 which is not included, so we will write it curly bracket and x such that x belongs to real number is a number, or a natural number will be the more perfect. Okay, will be a natural number comma, and minus 3 is less than x and x is less than 0. So this is our set in set builder form. For question number 2, this is question number 1. Now question number 2, 6 and 12 both are included, so quickly let's write x such that x belongs to natural number comma 6 is less than equal to x and x is less than equal to 12, so both are included, right? Okay, now question number 3, 6 and 12, 6 is not included but 12 is included, so again x such that x belongs to natural number and 6 is less than x and x is less than equal to 12, right? Now question number 4, I think I don't need to write this one. Okay, so question number 4, minus 23 is included but 5 is not included, so x no, this can't be a natural number, it will be integer. Okay, so integers are represented with q or z. Let me just check integers, positive I, okay, so integers are represented with z, rational numbers are represented with q. Are yaar, you should told me before, yaar. Integers I, right? Set. So by mistake I have written here something like n, this is integer, so integer are represented with z. Okay, now we have minus 23 and 5, so x such that x belong to z and minus 23 is less than equal to x and 5 is not included, so 5, right? Next question, question number 7, write a universal set would you propose for the each of the following? The set of right triangle, the set of isosceles triangle. So a set of triangles, set of triangles. Okay, so set of triangles, there will be all type of sets, and we can pick one: right angle triangle and isosceles triangle. Next, question number 8. Give the set A 1 2 3 5, B 2 4 6, and C 0 2 4 6 8. Which of the following may be considered as a universal set for all the three sets A, B, C? So we have to pick one of these, and we have to consider that all the elements of all these three sets can cover in this. So this is looking the big one. Let's see, 0 1 3 5. So 1 3 and 5, 2 4 6, 2 4 and 6. Now 0 2 4, 0 2 4, 6 8, 6 and 8. So this is true. Okay, this is the correct option number 3. So that's it for this video. In next chapter, in next video, we will see the Venn diagram and operations on set. So thank you so much for watching this video. I hope you will understand this and you will practice with your own. Thank you so much. Happy learning.